Hey everyone. Today we should have a pretty short lesson here. We're going to split this one up into 2 days. I'm guessing this one will take maybe 5 minutes here. Rational numbers, probably something you've heard of before. If not, you will hear of them. So our rational numbers, definition, important. 2 definitions right here, both important for your notebook. Rational number and irrational numbers. A rational number, what that means is it's any number that can be written as a fraction. That is the definition I would like for you in your notebooks. Any number that can be written as fraction. It'll look something like a over b, or any fraction that you've seen before. I know you've seen plenty of types of fractions. It's important to remember that we can write things like 6 as a fraction. That can be 6 over 1. So our integers are rational. It's not just about if they look like a fraction, but if they can be written as a fraction. So for example, if I did 0.25, that doesn't look like a fraction, but it can be written as a fraction. And that makes it rational. It's not about what you see. It's about if it has the ability to be written as a fraction. So for example, like I said, one example is 6, but another would be, let's say, 11. 11 doesn't look like a fraction, but we can quickly transition 11, throw a 1 underneath it, and there, it's a fraction. It's rational. It's about if it can be written as a fraction. All right, so knowing that that's a rational number is any number that can be written as a fraction, we can assume that an irrational number is any number that cannot be written as a fraction. I put in this little part right here, it says often non-perfect squares. That'll make sense to you in a second. I'll put an example in there. We'll talk about that a little bit later, but for now, maybe just jot down your notes. All right, I have a little chart here. Might be worth pausing, getting this in your notebook. It's a nice diagram that'll help you out. So it sorts rational numbers, and then inside of that integers, and inside of that whole numbers. So they all fit within rational numbers. Things on the outside would be things like pi, square root of 11, 10 over 0, things like that. Infinities in there. We'll talk about that one later. So those are things outside of the rational numbers. Inside, look at how all these can be written as a fraction. This right here is already written as a fraction. Right here, this is the square root of 49. Well, what is the square root of 49? That is equal to 7. Can 7 be written as a fraction? Well, yes, it can. 7 over 1. Another rational number. Look at this. We have a repeating symbol. This can be tricky, but repeating symbols are rational numbers. I know it's tough, and it's not easy to see how those can be written as numbers. This is kind of just like a little key point. Repeating numbers are rational. And a lot of times you're not going to be able to figure out how they're rational, but it's just a little tip to know that repeating numbers are rational. There is a way to write those as fractions. For example, if we had 1/3 is the same as 0.3 repeating. Other things, we got our negative 7 over 2, obviously a fraction. 0.25, we talked about that earlier. That's the same as 1/4, fraction, fraction. Our integers within, these can all be written as fractions. We can put them over 1, or they can already be over something else. And our whole numbers in the middle also can be fractions. Put them over 1, or they already are. Important to note right here, 0 is a rational number. You can write 0 as 0 over 1, rational. Okay, so that's pretty much the gist of our entire lesson. Our one little tidbit that I'm adding here, our perfect squares are rational. So that means 1 squared is going to be rational. 2 squared, obviously, these are going to be 4, 1, 9, 16, 25, 36, all rational numbers. We can make those into one, all put 1 underneath them, and they're all rational numbers. Likewise, the square root of all of these. So if we do square root of 1, square root of 2, square root of, or not 2, of these perfect squares. So 4, 9, square root of 16, square root of 25, square root of 36. These are all real numbers. 1, 2, 3, 4, 5, 6. So if we have these perfect squares, they are rational. Those imperfect squares, so if I had something like square root of 51, that is not rational. That is irrational. And that's when I come up here. I said often non-perfect squares, square roots are irrational. That's what you'll see a lot. Things like this and this. All right, so real quickly, we're going to sort out some of these. Let's start with this one right here. We're just picking if it's rational or irrational. 3 squared, we know that's the same as 9. 9 is an integer, which can be written as 9 over 1. So 3 squared is rational. Square root of 16, I know that one in my head is 4. 4 can be written as 4 over 1. That is rational. Pi, this one's just one you got to kind of know. There is no way to write pi as a fraction. That is irrational. That one's kind of a special little one, maybe worth noting. 0, we can write that as a fraction. We can write it as 0 over 1. We talked about that earlier. That is rational. The square root of 5, is there a perfect square for 5? No, there is not. Nothing times itself is going to be perfectly 5 that we can write as a fraction. Square root of 5 is going to be irrational. And finally, we have 4.35 repeating. I talked about those repeating numbers. Those are also rational. So a few special circumstances there. Backside, I got plenty more. We're going to just burn through these quick here. Rational or irrational, looking at the first one. Take a second to look at it. Say it out loud or in your head. That is rational. Can be written as 64 over 1. This one, think about it for a bit. Think about our rules. This is rational. This is really the same as 7 over 1, 2, 3, 4. There's our fraction for that. Pi, we talked about that one. That is irrational. Can't be written as a fraction. Square root of 7, does anything go into 7 perfectly? Nope. That is irrational. 1/2, that is already in a fraction. Well, duh. 0 over 1, odd exception here, rational. 0 can always be written as a fraction. 4 over 0, maybe one worth noting here. This is irrational. Anything divided by 0 is undefined and cannot be written as a fraction. This is a fake number. It looks like a fraction, but it's a fake number. Next one right here, this one is written as a fraction. We know it's rational. I briefly mentioned our last one here. This is just for good fun if you want to know. Infinity is irrational. There's no way to write it as a finite fraction because we don't know what it is. It's an infinitely big number. Some people like to argue that you could write it as infinity over 1, but a lot of people say that isn't the case because we don't really know what's sitting over it. It is an undefined number. All right, so there's your rational, irrational lesson. We'll have a second half of that on a later day. Big things to note for this lesson is that rational numbers can be written as a fraction. Irrational numbers cannot be written as a fraction.